Alright, here we are at my workbench. I have the adjustable gap receiver. A couple things you should know about this. There are 4 different versions of the receiver itself. Receiver 1, which we label as R1, is 3/4 of an inch on the mouthpiece receiver end, and it tapers down to just a little bit larger than a standard tube, and it meets up, the taper actually meets up with the mount part. So this is M5 or mount 5, and this is receiver 1. And not to make things confusing, but this mount, M5, works with all of our tapered receivers, and M6 works with all of the cylindrical receivers. If you decided one day that you wanted to have a cylindrical receiver on this mount, which is designed for tapered, it will still screw on there and it'll still fit everything exactly the same. The only difference is that cylindrical receiver then will have a little lip that goes to this taper. It just looks a little different, but these two were designed to go together. So R1 and R4 go with mount 5. And you're wondering why mount 5 and not mount 1, 2, 3, or 4. That's because the earlier mounts are for Harrelson Trumpets. This one's specifically designed to fit on something like a Bach or a Yamaha. Alright, so Oscar, take a look at those for me. Here we are going to take this Bach Stradivarius apart. It's pretty simple. I'm pretty sure most of you could do this on your own in your basement or your garage. You're just going to need a torch, a propane torch you can pick up for 20 bucks, and some solder, preferably instrumental solder, some wire, and maybe a couple little clips. You can use bobby pins sometimes if you bend them, and some way to hold the trumpet, maybe like a wooden vise, and I'll give you some ideas in my blog. But I'm certain that almost everyone could buy an AGR and do it yourself. If you want a really great job, then go to a professional and ask them to buy the AGR and offer it in their shop. Or you could just bring it to them and pay them. But either way, it's relatively simple to get this on there, and I guarantee you it's not going to take you at home more than half an hour. Probably won't take me more than 15 minutes. So, it'll take longer today though because I'm showing you every step. First thing you want to do is take your pistons out of your trumpet. I'm kind of surprised they even come out of this trumpet, because this thing is old and corroded. Okay, but it looks like everything came off. I'm just going to set it up here for a minute so we can see it. I have a fancy trumpet stand. If you find that you're working on your horn a lot, you may leave bottom caps and top caps on. You may put them back on so you don't damage the threads. A damaged thread on a Bach trumpet is very common because this is a very thin area. So please be careful if you have a Canstel trumpet, a Schilke trumpet, or a Bach. Those are the ones that are prone to the most damage. Be very careful. I wouldn't do what I've done right here unless I were being very careful. You can see just by setting this down I could bend those threads. Alright, so now I need to take this brace off on the top and this receiver. And we'll take that over to the soldering booth. When you're soldering, there are fumes involved, and when I was young, I was about 17 years old when I started messing around with trumpets. I had inhalation poisoning a couple times just from breathing the fumes. Usually the acid flux that we use can be pretty harmful. So you want to have well ventilated areas or have some kind of filtration system. I have built a filtration system that has a charcoal filter, so that reduces my exposure quite a bit. Alright, so I'm turning that on right now. You might hear a little bit of noise. I'm going to fire up my torch. Believe it or not, I build all of my trumpets with those cheap torches that you see at the hardware store. I always have, and that's because they create a really wide flame. They can heat things up pretty quickly, so I don't spend a lot of time trying to heat a large area with a small flame. Alright, first thing I'm going to do is take a pair of pliers, and I've got a pretty large set, and I'm going to heat up this brace, just moving the flame underneath it until I start to see it spit a little solder, and then same on the other side. and I'll probably have to go back and forth a couple times. And once I'm done, it'll just pop right off. It's very hot though, hence the pliers. There it is. Alright, so I want to minimize my amount of work later. So I'm just heating these up and removing the solder by flicking it. I could also wipe it with a rag. Now here I've got extra solder. I'm going to take a Q-tip and just remove that too. I can flick it all over the place because I've got this nice solder head that will take the abuse. Don't do that to your basement, you might start a fire. Alright, turn this horn around. I'm going to get a little more off of here, even though I'm not going to reuse this receiver. We'll take pictures of it afterwards, before and after. Okay, so that's done. Now let's see how easy this receiver comes off, because I can tell it's been taken off before. Maybe somebody tried to adjust the gap already. It's off. Okay, so while I'm here, I'm going to heat it up a little more, take a rag, wipe that solder away. Alright, so I've removed the receiver and the brace. Next step is to prepare the lead pipe for the new adjustable gap receiver mount. And it has to be perfectly clean. So I am taking some shop roll, which is nothing more than basically a cloth backed sandpaper that comes in a long roll, and I'm sanding it. I cut it up into strips and now I'm just sanding it down to remove the solder and clean the surface so that when I solder the new receiver mount on, that it's a nice clean perfect fit. Preparing the lead pipe could take a few minutes depending on how much solder is on it and of course if it's the same size or not. If it's too large of a lead pipe, you may have to sand it down a little extra to make the mount fit just right. Now I can see that somebody did something unusual to this lead pipe. There's a flare at the end. So I'm guessing what happened here is someone took a hammer or something and tapped the receiver and eventually flared it out. But it could be that they took the receiver off, intentionally flaring that and then put it back on. I really don't know what happened. All I know is that normally there's not a flare at the beginning of the lead pipe. So I'm going to take care of that with a tool. This is very unusual that you would find this, but it's also easy to fix. This is just a shrinking tool, and it shrinks flared tubing back down to where it's supposed to be. And we're almost there. Okay, now I'm going to take my mount and just get a rough fit and see how it fits there. Looks like it almost goes all the way down. So it should go all the way to the end. There's a little tiny lip in there that measures 350 on the inside diameter. And it goes most of the way. But I'll just mark it for the camera. It should go about to there. And right now, it only goes that far. And that's because it's still got a flare on the bottom of it. So I'll take care of that. And that flare could have caused a larger than normal venturi size. Okay, it's almost there. I'm going to sand a little more because I do see just a tiny bit of solder here. Right on the end. If you're sanding the end and it always falls off like that, a trick you could do is to put something in there. So here I'm just sticking the end of a marker, and that prevents it from falling off. See that? It makes your life a little easier. And when you're sanding, if you have to remove a lot of material, longer strokes with the sandpaper will remove material faster. You can thank my dad for that piece of advice, although I'm sure he heard it 1,000 times from his dad. Alright, now we're almost there. It looks like it'll snug right on now, but I do see a tiny bit of flaring there. And like I said, that's pretty unusual. There, it went all the way on, and I can see it's all the way to the end here. So we'll stop the camera for a second just to get a photo of the fit. Okay, so the receiver mount does fit, and it looks like everything's prepared there. But remember, I took the top brace off, okay? I need to put the top brace back on, otherwise we'll lose some efficiency here. And the way that I prefer to position a top brace is to put it on backwards. And I used to offer modifications that did this. And quite a few people thought I was nuts. Until, of course, they played the horns that had been reversed. And then it's kind of irrefutable evidence. When a horn doesn't lock in F, G, A, that part of the staff, above the staff, you know, those notes can be troublesome. But after reversing this brace, most horns would lock in really well. And there is a reason for that. It really comes down to antinodes setting the tubing into vibration. And that's 50% of what I do here, is just prevent antinodes from robbing the energy out of your standing wave. So the standing wave efficiency that you see we talk about so much on our website, it's what I think about all day long. Alright, so now I've cleaned the metal where I'm going to put the brace and reverse it. So I'm going to go grab that brace and clean it. Here is the brace. If you don't have a lot of tools at home, then you may have to use a Dremel tool, which would be like kind of like these rotary grinders. Or you could hand scrape it with a standard scraper. Here's one. You could take a chisel from the hardware store and on a grinder make it round. So I'm scraping off the solder. Let's do it like that, it's easier to see. Okay, so if you had removed this solder under the flame, then this would be a little easier. But since I've done it for many years, I'm almost done. The next step you would want to do is take some sandpaper and sand it all the way down to bare brass. I'm going to do that on this piece of wood. I'm not using my machinery to do this, just because I want you to see how you could do it at home. I would be done by now if I used my machines, which are really large wheels that have soft grinders on them. Okay, so I finished sanding. It's down to bare brass on both sides. Now I need to position this where it's going to go, and then if necessary make some bends, because we're putting it on backwards. And it looks like this one doesn't need much, but you can see it's not quite there, there's a gap. So the easiest way to bend this is in a vise. There are lots of other ways to bend it too. I just happen to have a little spot on my bench where I can do it. And that's a pretty decent fit. So for today's video we're gonna go with that, and this will be on here. The next step is to flux the area. You want to flux all the parts that you're going to use, and I like to set it all up at once. So I'm going to put flux on the inside of the receiver, or I'm sorry, the mount. And flux is really just an organic acid paste, usually, that will vaporize when you heat it. And that vapor prevents any kind of oxidation from happening when you do the soldering, because high heat will oxidize things really quickly. So an acid flux will vaporize, create a vapor barrier, so the solder can touch the metal when it's clean, rather than after it's oxidized. One thing I didn't do is check the bore or the venturi, and I can adjust that now. I normally do adjust venturis when I build horns. Typically a Bach trumpet should be 341 to 343, most of them. This is a 340. Here we have a 341. And that fits just barely. I'm going to open it just a little bit here. And this is a 342. And we're going to leave it at a 342 because my Summit 1 is a 342. we'll just go with that. So you could set yours really by using the inserts on the adjustable gap receiver. So you don't have to do it the way I did, because this will allow you to be flexible and to change it over time. Now, I have some little spring clips. You could use steel wire to do this next part. I'm going to flux all the areas that receive solder. And to be sure I know where they go, I'm going to position this up here. Oh, I've got it backwards. And then I can see where the flux needs to go on the horn. You don't want too much flux around there, or it just allows the solder to flow in places you didn't intend. Alright, a little more down here. They also sell something known as anti-flux, which is nothing more than pumice that is mixed with water or alcohol. So you could use some pumice and alcohol mixture to spread around the areas where you don't want solder to go.